All right, everybody, this is probably assigned to you on Monday the 14th. This is EOC Subpart 3. It's 22 questions long. We're going to go through the answers. I may end up splitting this up depending on how much time it takes because the file sizes are getting too huge, all right? The tech piece of this recording stuff really put me through my paces this week, and I finally realized iPad is the best quality for sure. Uploading it to YouTube, YouTube takes care of compression and file type and everything, so it'll just play anything. So I decided that was the best way to go. This is EOC Subpart 3, 22 questions, and we'll see if we need to cut it in half depending on how long each one takes. All right, so consider the functions shown. Absolute value, hopefully you remember those vertical lines are absolute value of x plus 2 and x plus 8. This is a calculator problem. We're going to type both of them in. Absolute value is under the math, and then you go to the right under number. Absolute value is right there, all right? So we're going to put in x plus 2. Let me delete everything else on that line. I wish a calculator, I wish the things in the calculator moved more like on a computer. I don't know why they can't simplify it a little bit. All right, so we're going to graph it and see where they cross. When they're equal, they cross at negative 1, 2, 3, 4, 5, negative 5, comma 3. So we're going to go with M on that one. Yep. All right, let's move on. Number 2. This one threw me for a loop just a few minutes ago when I worked on solving it, but it isn't as bad as it looks. All right. You know how I'm always saying you can always just substitute something similar. You can use a similar example to remind you how to do something that's a little more complicated. This is a good example of that. So instead of seeing x plus a, I want you to just see x. We're just going to substitute x for our x plus a, and then at the end, we're going to substitute it back in, all right? So we're going to call that x squared instead of x plus a squared plus 5x plus 4. Now this would factor into two binomials, what multiplies to get 4 and adds to get 5, x plus 4, x plus 1. Now we're going to resubstitute back in x plus a instead of x. So that ends up being our first. It turns into a trinomial instead of a binomial, but that's okay because that ends up being the answer. This one right here, number 3. I know that was a weird one, trinomial factoring. The 5 trick would work for this one. It would just take a few minutes to plug everything in, especially this number 4 answer. But if you plug 5 in, you'd have to plug in a number for 5 and a and make them different numbers, like 5 and 7. That might work if you didn't see what the pattern was. My initial thought was I tried to square that and then multiply that through, but I ended up getting some terms that I didn't like, nothing combined. It didn't look like any of my answers, so I went with that substitution solution. Write a polynomial function of least degree with integral coefficients that has these zeros. If these are the zeros, that means they are the solutions to the problem. Oh, now we know the answer is B, but remember, it's not about knowing that the answer is B, it's about knowing how to solve it, right? It's about knowing how to solve it. So, let me get it back up here. I had the wrong tool selected. Here we go. All right, I didn't go over this a whole lot with you guys, but when we have the zeros of a function, we have the solutions. They've given us the solutions to one of these, but we don't know which one. You take each solution and create a binomial factor. So it's kind of like x plus 0 would be a factor of these. Now we did this a lot. If it's a factor, then that tells you that that's one of the zeros, but we didn't go from the zeros back to the factor a lot. So that's one of the binomial factors. This is one of the binomial factors, and this is one of the binomial factors, all right? So that's just x times, I'm going to go ahead and FOIL this, x squared, outers is minus x, inners is minus 2x, last is plus 2, and then I can Bounce this over here. Minus 2x squared plus 2x. These middle two will combine into negative 3x squared, and that should be my answer. X to the third minus 3x squared, mix that up, plus 2x. X to the third, there we go, right there, B. All right, and like I said, we learned earlier that the answer was B, but it's about knowing how to solve it and not necessarily about finding that answer. All right, here we are, number 4. Population over a period of T years, I was thinking town, the population over a period of T years since the town was founded can be estimated by this exponential growth formula. The town's growing. How many years? We're looking for T. If it's asking for years, we're looking for T, that's the time. Before the population is 11,200. All we do is substitute in 11,200 for the population, and then we are going to solve for T. All right, divide both sides by 5,600. That ends up being this. I'm going to switch signs on you here because I like my variable to be on the left. Okay, there's what we have. Equals 2. I just switch sides. And anytime we're dealing with E, you're going to use the natural log, okay, of both sides. I'm going to take the natural log of both sides. What that does is pull this exponent down. I end up with 0.059t times ln of E equals ln of 2. Guess what? The ln of E just asks what does E need to be raised to become E. The answer is 1, so that's just equal to a 1. I can divide both sides by 0.59, which I haven't actually done. So 2 divided by, ln of 2 divided by 0.59 gives us 1.17 years, and that's not one of the answers. I wonder if I'm 10 off. I am, because I didn't move the decimal enough. So I'm going to go grab that answer again and divide by 0.059. That's going to give us 11.7 years, or C. All right, let's check that just for fun. Yep, there we go. All right, Joyce deposited $5,000 in an account with an annual interest rate of 6% compounded annually. Now we're in luck because it's compounded annually. That means we don't have to deal with any weird values of n. You know, when n is when it's compounded quarterly, n is 4. If it's compounded monthly, n is 12. N is just 1 in this case. So we can use our table of formulas. The table of formulas that you are given in order to take this test, and we can use the compound, let's see, I can't read it upside down, compound interest formula, but n is just going to be 1. So it's going to be the equivalent of just the compound growth formula, all right? So all we got to do is multiply 5,000, which is our A, or our principal, times 1 plus 0.06 to the 10th power. Type that in your calculator, you end up getting $8,954. So they have to leave it in there 10 years for it to be equal to that, all right? All right, let's check that answer. It should be D. Yep, there we are. All right. Number 6, no calculator, it says. So some of the no calculator ones are kind of mixed in here, so don't worry about that. Just look at this one, and we're not going to use a calculator on it. Okay, Lily and Adam are simplifying this expression. First of all, just go ahead and simplify that expression. I know that's easier said than done. It's rational exponents, rational numbers being basically a fancy word for fractions. So we're going to take this thing and we're going to go 64. Anytime you have a 2/3, like a fractional exponent, we're going to say 64 squared. We're going to pull that 2/3 apart into 2 times 1/3. So you can either write it like this, pull that 2/3 apart, or like this. Either one of those is acceptable because all we've done is pull 2/3 apart into 2 times 1/3. Remember that a 1/3 exponent is the cube root. All right, so Lily takes the cube root of 64, which looks like this, and squares the results. I already like what she did. Adam takes the square root of 64. No, neither one of these take the square root of 64. That would be 64 to the 1/2. That's square root of 64. We do not have square root. We do not have 1/2 up here at all. I do not like what he did. Only Lily is correct. Okay. Let's double check that. Should be A. Yes. There we go. See, I do not have all the answers. I don't know everything. The difference between you and me is I've been doing it a lot longer, I suppose. I got a lot more practice at it, so all these rules kind of come back to me quickly. But it's not a matter of more talent with it necessarily. It's just a matter of I kind of like it. It's sort of like puzzles for me, as long as I know the rules, and I know most of the rules for these puzzles. And I still see one every now and then that looks kind of confusing. This is one of those. A circuit has a resultant resistance of blah, blah, blah. Basically, he just wants to solve this equation, all right? All the rest of this information, just the story behind that. So, using numbers 1 through 4, put the steps in order in which they should be performed. Now, I do not know the answer to this. I looked at it earlier and thought, well, I can probably work that on the fly. So what I would probably do is cross multiply, and I would end up getting 2 times 6 plus x, which is 12 plus 2x, and that would equal 6x times the invisible 1 on the bottom of the 2, right? And then I could subtract that from both sides. I could subtract 2x from both sides and divide both sides by 4, and I should be done, right? So let's see what the possibilities are. Distribute the term. Now multiply both sides by 6 plus x. That is the same thing as cross multiplying, okay? Multiplying both sides by 6 plus x. Then subtract 2x from both sides. No, we're going to distribute the term first. I did that in my head as I brought the equation down. Then we're going to subtract 2. Then we're going to divide both sides. So it's multiply, distribute, subtract, divide, multiply, distribute, subtract, divide. It should be B. There it is. All right. Good listening, by the way. I can already tell I'm probably going to divide this one up into 2, just depending on how long this is getting. Yeah, it's almost 13 minutes. So I will divide this one up into 2. I'll do 4 more. I'll do through number 11 since this is 22 problems. System of equations is given. Select all values to the nearest tenth for which they are equal. System of equations. To solve a system of equations, you're going to plug each one of them into y1, one of them into y2, and we are going to see what we get. All right? System of equations. So we got negative x squared minus 2x plus 6, and we got 2x squared plus 5x plus 3. Let's see where they cross. All right, we're going to do, I can't tell immediately where they cross, so we're going to do our intersect. Intersect can be a little tricky. You just want to get really close to one of the intersections on the first curve, then it goes to the second curve, then you hit enter again, and we have one of the intersections, the x value is 0.3699. So 0.37. I don't see that one. Make sure I've done everything right. X squared minus 2x plus 6, 2x squared plus 5x plus 3. Yep, okay. Let's try the other intersection, see if we... Negative 2.7. All values for which they're equal. I'm going to try that other intersection one more time because the one on the left worked just fine. .3699, so 0.367. It's not there. So let's see if that's the only answer. Have they tried to trick us by showing us that? No, we've got to get a pair of answers. Why is the answer that I'm choosing not coming up? Let's see. Try it one more time. Intersect. 0.3699. 0.367. Oh, I guess that goes to 0.4. To the nearest tenth. I didn't read the directions, guys. You got to read the directions. Come on. You should have warned me about that one. Somebody should have noticed that. I mean, Cameron, Jordan, you guys are watching. Emily, somebody? All right. So 0.4. So I'm going to go with A and D. There we go. C. Yes, it is C. Very good. All right, 3 more on this video, and then I'll do the next ones on this one. This is EOC Subpart 3. I'm doing 1 through 11 right now. Consider the inequality. Oh yeah, I remember this one. I saw this one earlier. It's very straightforward. We're just solving it. All right. A lot of times the answer is easier than the question. All right. It'll confuse you reading the question. That's 51. Minus that is 42 greater than or equal to bx. What would B need to be in order for us to end up with a 7 over here? Well, we'd be dividing by 6. So we'll go with B equals 6. All right, there it is. Okay, bird's in a tree and drops a twig on a rose bush. All right, rose bush is, we just want to know how long it takes to land on the rose bush. So here's our function. The function describes the falling of the thing. And t is the time in seconds. So we want to know at what point is t make the height equal to 0, all right? A bird is a bird's at 150 feet up, drops a twig on a rose bush 140 feet below. So we're only going to solve for 140 over here, all right? So we're going to say the height is going to be 140. When does t, what value of t gives us that number? All right, we're going to subtract 50 from both sides. We can solve this in the conventional way. 40 minus 150, we get negative 10. Now, height and time can be a little confusing. I get a little confused about it. Physics is not really a strong strength of mine because we get into negatives a lot of times, in which case we do have a negative right now. So negative 16 t to squared, we're going to divide both sides by 16, negative 16 rather. That gives us 0.625 equals t squared. We'll take the square root of that. I was hoping it would come out even. 7, 9. That's none of the answers, all right? This is in a tree 150 feet up, drops a twig, it lands on a rose bush 140 feet below. So the change in h is going to be it's dropping 140 feet. The bird's 150 feet. We subtracted that from both sides. Maybe I'll try subtracting the 140 from both sides, and we'll plug it in the calculator. All right, let's try that. It would be negative 16x squared plus 10. And then we'll just zero that out. Zero, left boundary, right boundary. Again, I got 0.79. 0.79 seconds. All right, that is one that we'll have to, like I said, physics is not my strength. We're dropping 140 feet, so h should be 140 feet. T represents the time in seconds, and we're solving both the, we're solving this, and I got the same thing. What am I missing? Because I keep getting 0.79 seconds. But that doesn't sound right. It couldn't drop a twig couldn't drop 140 feet. All right, we're gonna put a pin in that one and we'll go over that one when I get back, all right? I thought that would work out evenly. It did not work out. So let's take a look at what the answer is, by the way. The answer is 2.95 seconds. I did not figure out how to find that, so we will move on. Number 11, last one for now. We'll do 12 through 22 in just a minute. If the terminal side of angle, this is another one that we're skipping for now because this has to do with the unit circle, which we have not covered yet, all right? Unit circle is a different way of thinking about angles, all right? All right, so I'll pause it right there and we will resume in just a few minutes.